In this section, we're going to take another way that you can start putting functions together. And essentially, this is going to involve the operations that you're used to. So, how do you add functions, subtract functions, multiply, and divide them? When taking care of each of these operations, pay close attention to two things. One, what effect does this have on the domain of the function? And two, are we dealing with some sort of input, or are we leaving the input general as x? So let's get on to the first of these operations, adding and subtracting. When you add or subtract functions, you basically go through and start adding or subtracting the like terms. The notation that you'll often see for this looks like this: f of x plus g of x, or f of x minus g of x. And you can see that your intuition, kicks in pretty good, that you're essentially going to take both functions and either add them or subtract them. Now be careful, because there is another alternate notation in order to do the same exact thing. The alternate notation looks like this: f plus g of x and f minus g of x. Now, even though it looks different, it does really mean the same thing. And oftentimes the notation on the right is more common than the one on the left. Now, what I often do in my work when I see the notation on the right is I will switch it to the one on the left. This is because my brain works a little bit better with that notation on the left than it does with the one on the right. Now, the only thing you have to really be careful of when using adding and subtracting is just be careful with your distribution property. Sometimes when you are subtracting a function, you may have to distribute a negative sign all the way through that second function. Now, adding and subtracting does have a small effect on the domain of the new function you create. Basically, the domain of that new function will be the intersection of the domain of f and the domain of g. So a good way that I like to describe this is, first I think of the domain of f and g, and I take whatever values they both have in common. And that will be the domain of my new function when I either add or subtract them. So let's see an example to see how these operations work. Up above I have two functions, f of x equals x squared minus 4, and g of x equals 6 minus x. And in my first example, I want to take f minus g and then use an input of negative 6. You'll notice that I'm using that alternate notation that has f minus g of some sort of input. And the first thing I like to do is, of course, switch it out. So the alternate one that makes a little bit more sense in my mind is f of negative 6 minus g of negative 6. Now the advantage of looking at it this way is I can see that I essentially want to plug in a negative 6 into f, a negative 6 into g, and then just subtract those two values out. So let's go ahead and do that. So I've plugged in a negative 6 into f, looks like it needs to get squared in minus 4, and I need to plug in a negative 6 into g. Now pay close attention. I've also put in an extra pair of brackets around each of the functions. This will help me remember that I need to distribute the negative sign in between the two. Okay, so let's simplify this a little bit and see what we get. So square the negative 6, I get 36. On the right, since I'm subtracting a negative, I get positive. Continue a little bit more, so this turns into 32 minus 12. And it looks like my total output when I'm all done is just 20. So when I plug a negative 6 into f minus g, I get an output of 20. Now let's go through my other example, f plus g of x. Now notice this is using addition, and I'm not really using a number as my input. I'm just leaving things nice and general with x. This means when I get all done, I will not have a number as an output. Instead, I'll have a new function that represents the two when they're added together. Alright, so let's go ahead and go through this example. So I'm going to switch to that alternate notation so I can see better what I need to do with the functions. So I need to take f of x plus g of x. Now since I'm leaving things nice and general, I'll just go ahead and use x squared minus 4 for my f of x and 6 minus x for my g of x. There we go. Now I want to go through and start combining like terms. And this one doesn't have a whole lot, but I can combine the negative 4 and the 6. So I'll go ahead and put those two together, and then go ahead and just reorganize things so that my powers are in descending order. So x squared minus x plus 2 represents my new function when I'm all done. and it's essentially both f and g added together. Now let's move on to multiplying two functions together. When you multiply two functions together, this is very similar to, say, multiplying polynomials. One thing you want to be careful for is, again, there's two different notations used to multiply. On the left, I have the notation that kind of uses your intuition, that you'll take f of x and be multiplying by g of x. The alternate one that's a little bit more common says f times g of x. Now, oftentimes, if I see the notation on the right, I'll again switch it to the notation on the left and end up carrying it out from there. Now, remember, when you're multiplying functions or any type of, say, equations, you want to make sure that every term in one gets multiplied by every single term in the other one. Now, oftentimes to do this, we may have to use some techniques just to get the job done, such as using FOIL to make sure that our first, outside, inside, and last terms get multiplied, or some alternate method to make sure that all the terms really do get multiplied out. Now, this will have an effect on the domain, but it's actually the same effect that we had for adding and subtracting. The domain of the new function we create will be the intersection of f and g's domain. So look at the values that are in f's domain and g's domain and see which values they have in common. This will be your new domain when you multiply them together. For our last operation in this section, we'll look at dividing two functions. The biggest thing you want to remember when dividing two functions is that sometimes you can actually simplify them a little bit further. So rather than just taking one function and putting it over the other one and stopping, take a moment to look at it and see if anything might cancel out. When you get into the notation, again, there are two different types. The one on the left says you'll take f of x and you'll divide it by g of x, and it seems to make a lot of sense. The one on the right just takes the names, but it really does mean the same thing. It says f divided by g of x. Now, this will have a huge effect on the domain. The reason is, when you have division, you have to be careful that you're not dividing by 0. Well, notice in the bottom we have an entire function, g of x. So our domain will be the intersection of f and g, whatever values they have in common, along with whatever values do not make g of x 0. Okay, so here's a good way to describe all that information. When determining your new domain, first look at the domain of f and the domain of g. Take the values that they have in common. Then take a look at g of x and see if it ever equals 0. If it does, throw those values out. What you're left with is the domain of this new function f divided by g. Alright, now that we have the last of our operations, let's again look at some examples. So you'll notice that I'm using f and g from my previous examples, x squared minus 4 and 6 minus x. And the first thing I want to do with them is basically multiply f and g together and use an input of 2. Now, that's using the alternate notation, so let's go ahead and switch it to something a little bit more intuitive. Something like this. F of 2 times g of 2. Now that first one says I basically want to plug 2 into f, and then plug 2 into g, and then multiply things out. So let's go ahead and do that. You can see that I basically have one function multiplied by the second one. So we'll simplify by squaring the 2 and subtracting 2 from the 6. All right, doesn't look too bad. So I got 4 minus 4 times 4. So I'll get 0 times 4, and in the end, looks like I'll get an output of 0. So this says when I use a 2 into the function f times g, I get an output of 0. Now let's look at the second example. This one says f divided by g of x. And notice how I'm not using an input here, I'm just leaving it nice and general with x. This means when I'm all done, I will not have an output, but instead have a general function. Okay, so let's give it a try. So essentially I want to look at this as my function f of x divided by my function g of x. And then I'll go ahead and put the expressions for each of these functions in. So x squared minus 4 divided by 6 minus x. Now, this is the point where you want to take a look at it and make sure that you can't simplify it any farther. You may want to check to see if you can factor values out of the top and factor values out of the bottom, and then if they're the same, cancel them out. In my particular example I have here, I could factor the top into x plus 2 and x minus 2. Unfortunately, neither of those pieces would cancel with any of them in the bottom. So this is as simple as it gets. So this expression right here, x squared minus 4 divided by 6 minus x, represents my new function when the two are divided. Now, real quick, let's think about the domain of this one. The domain of f is all real numbers, and the domain of g is again all real numbers. So the domain of this one, I would start by assuming that I could use all real numbers. But I also have to be careful. I don't want my bottom function to ever equal 0. Well, it looks like it will equal 0 if I try and use x equals 6. So I'm going to throw x equals 6 out of my domain. And instead, I'll say that the domain of this new function is all real numbers except for when x equals 6.